Sitting on the bench, I've got this Revox tube slash valve amplifier I'm repairing for a customer. This is circa late 50s, early 60s Revox studio amplifier, twin channel, very low power capability, probably about 10 watts RMS per channel. Pretty straightforward amplifier, nothing, no bells, no whistles, nothing like that. It's in lovely condition, beautiful condition cosmetically, you know, hardly a mark on it. There's a bit of a mark on this on one of the side cases, but considering its age, it's in lovely condition. Now, the owner of this amplifier is keen on his hi-fi gear and audio equipment, and has actually been inside and had a look inside, and actually found one of the valves was broken. So the request is to actually get this amplifier going properly with the new valve, to go through it and check the components that are inside, particularly capacitors, obviously. He has requested that I don't replace anything that doesn't need replacing, so I need to check ripple and noise on power supply capacitors, etc., and obviously grid coupling capacitors, make sure they're not leaky. I had a look inside when I went round to pick it up, and he had the cover off it, and it's basically got the mustard cap capacitors, so they're going to be pretty reliable. They shouldn't be any problem anyway. But he has requested I replace all the valves in it, and he's actually bought some Siemens valves for it. So one of the output valves was damaged, so they're obviously not a matched pair anymore. So we should have a complete set of valves for this amplifier. So that's going to be the sort of like the beginning this evening. We're going to first of all we're going to get the old valves out and store them away, because I think he wants them back for other gear, which is fair enough. I would probably be interested in actually doing an emissions test on them with my valve tester, just to see what they perform like. Make useful for the customer to know the emission quality of these valves if he wants to put them in one of his other amplifiers. So yeah, what I'm going to do briefly now is to go through the schematic with you, and we'll sort of like run through and see what we need to check, and try and work out how this works. It's a pretty straightforward amplifier. It doesn't look like it even uses any feedback. It looks like it's a straight amplifier. But it should be interesting to hear a stereo valve amplifier in the workshop. I haven't heard a valve amplifier for over 40 years. Not at my own residence anyway. I have heard them in other places. But so let's get set up to look at the schematic, and we'll go on from there. So here's a schematic. It's fairly straightforward, as you can see. We've got our phono preamplifier here, main preamplifier, tone selection controls here, bass and treble controls, and then basically we feed into our power amplifier stage. There's a balance control here, and there's the first drivers, there's the push-pull stage, output transformers here. So we need to go through and check basically obviously the power supply section here. We've got the power supply here, and we've got various rails for doing different things. There's a minus 26 volt biasing for probably one of the grids. We've got this supply here, various high tensions, 170, 185, 225, 250, so need to check all those. We need to also check all, obviously, the resistors in here to make sure they're all within tolerance. Hopefully they are, because there's going to be a lot of resistors that need changing if otherwise. I've got a bridge rectifier here, selenium rectifiers here, so we need to just check, see if I make sure our voltages are within tolerance. And then we need to start going through and having a look at some of these valves. So we're going to replace these valves. That's V1, that's one valve, V2 is another valve, V3, V4, all the way through to V8. We need to check our grid coupling capacitors, which are these, for example, C6. So we're coming off an anode here and probably feeding straight into a grid. We need to make sure that those caps are good. They're mustard caps, so they're more than likely going to be fine, which is good. Same here, any of these anode caps, C10, and that's C10 there. You need to check those, make sure that all those caps are good. We can do that basically by just putting the new valves in and checking the voltage on the grids. If the grid voltages are sort of in a few hundred millivolts, or sort of like a volt or something like that, that shows that capacitor is working perfectly okay. We need to check that because we don't want to put any DC through the valve. If you start elevating the grid positive, what happens is there's a lot of current starts flowing between the anode and the cathode, and you're just going to burn the valve out, and just over biasing the valve. So we've got to go through that. I think the other complaint there possibly was noise on the output stage. Now, I'm not entirely sure what that could be. That could be a noisy carbon resistor. It could be a number of things. It could be a noisy valve, a valve failing, but it's more likely to be something like a noisy carbon resistor. It's quite a notorious problem with these amplifiers, well, any amplifier with carbon resistors, to become a little bit noisy with time. So I think the thing to do is take the top off it, have a look inside, have a look at the valves, see what we need to do. Maybe get the valves exchanged first, and then we'll maybe just do a few static checks on some of these cathode resistors just to see if they're in spec, and see if they're not, see how far they're out. I think these will probably be 10% tolerance on these resistors anyway. What we do need to try and do is keep the balance of the amplifier the same, so we need to keep the left and the right, or 1 and 2 as channel 1 here, channel 2 as Revox call it, the gains similar or very close, as close as we can. So let's let's get the top of the amplifier and let's see what we got. So this is the inside of it, and what a lovely way it's laid out. Well, it's absolutely almost perfect for repairing. The only thing is getting up behind the back of some of these strips here. It might be a bit difficult to change capacitors and things, but as you see, these are all mustard cap capacitors, and they're known to be totally reliable. And he certainly didn't want those changed because the audiophiles know that the mustard cap capacitors offer very good sound quality, and I've got no intention in changing a capacitor that's perfectly okay. So easy enough to work on, as you can see. Let's have a look, tip it up so you can see a bit clearer. And so this is alignment of valves. Here's our push-pull stage for channel 1 and channel 2. Here's our pre-amplifier valves, are probably these two here, the C81s. And this is probably the phono stage in the shield here. Twin transformer, well, two transformers, three transformers, aren't there? There's the main transformer and the two output transformers. The bridge rectifiers are underneath the unit, and we'll turn that over in a minute just to have a look in there. But I think the first thing we'll do is we'll get the valves out, and maybe go and get the box of valves that he supplied with me. Just make sure we've got all the valves we need, make sure they're the correct valves obviously, and then we will start swapping the valves out, and then we can start going through and maybe checking some of these lower value resistors, particularly the higher power ones, just make sure they're in the ballpark figure, and then we can have a think about powering it up just to see if we can find this noise problem. But it's in beautiful condition. It doesn't look like it's done a lot of hours. Those valves don't look like they've done a lot of UC, haven't had a lot of use either. As you can see, they're sort of, the glass is nice and clear, there's no sort of discoloration. The getter's nice and bright. So I think we'll probably find this amplifier is in pretty good condition as it is, but it probably just needs a new set of output valves. But let's get these other valves and we'll have a look and see what we've got. Okay, 4 Siemens valves, so these should be ECL 86s, and they are. So we're just going to replace the output valves with these valves. Just check to make sure they're okay, and the getter's nice, and obviously they're not second hand, and just make sure they are new valves. I'm sure they are, but no problem with that. That's a good start. Siemens 8, there we go, ECL 86. So let's get the valves changed then. So we'll start by we'll turn the amplifier around to get to it a bit easier. You can see also what I'm doing here. Zoom in a bit. So we've got 4 output valves here. So we're just going to simply remove these. And what I'm going to do, I'm going to put a dot on the 2 that were matched, in theory, if they were ever matched. So we know which valves were matched, and we can actually use those in a push-pull amplifier and in theory get the lowest distortion. So let's get these valves in. Sockets are nice and tight, that's good. Because there's no support on these valves actually. I'm surprised. I'd expect them to have some sort of support. but they just sit on the horizontally in the amplifier, so there's a bit prone to vibration and things like that. Looking at the valve pins to make sure they're clean. They all look pretty bright actually, so that looks pretty good. This is one that the valve failed. I'm just going to clean that socket up with a bit of isopropanol just to get any muck out of there. But I shouldn't think that'd be a problem anyway, but it is a bit darker than the other ones, so let's get a piece of cloth and give that a wipe out. All I'm going to use is a bit of isopropanol just to try and remove some of that discoloration on that valve's holder. It's a bit brighter. Good. Pop the final valve in. It's a bit tight to get in that. The valve pins are straight. Right, I'm starting to wonder if there's a broken pin off in there. So let's pause the video whilst I need to check that connector to make sure there isn't a broken pin from the old valve still in there. Okay, this is the valve socket I'm having problems with. And if we work around to position number 3, if I shine a torch there, you can see it's not very clear, but you can see there's a pin still in that valve holder. So I need to get that pin out, and I don't know how I'm going to do that. I'm going to have to try and get it out with a pair of tweezers maybe, or a pair of pointy nose pliers, but I obviously can't put that valve in whilst all the time that pin's in there. So the next step is to try and remove that somehow, and see if we can either remove it, or the worst case scenario is try and put a new valve socket in there, which I don't really want to do because that's a major sort of wiring job on the back of the amplifier. If I can get that pin out, that would be much easier. So let's see if I can fish that out with a pair of pliers and go from there. Okay, I've tried everything to get that pin out. It's not going to come out. I don't know what the alternative is really. I think we're going to have to replace this valve socket if we can get one that's the same. And you can see it, and you can just about see it, and that it's just that one there. You see that little pin bit left behind. I've tried digging it out with tweezers. Nothing will move it. It's stuck in there well and truly. It's well and truly jammed. So I'm going to have to try and find another valve holder and contact the seller and contact the owner to see if what he wants me to do. He might have something, or he might know where he can source one. But in the meantime, that's the end of part 1. And hopefully part 2 will come up. We get a resolution to this problem.